Hello, in this video I will show how we can perform 4-bit addition with VHDL language using Basys board. We will code step by step, run it on FPGA and visualize the result with LEDs. I am not explaining the subject. It's a simple application anyway. Let's start directly with the example. 2-bit plus 2-bit addition should be 3 bits. The output will be 1 more than the numbers of bits added. The causes overflow. Or if 2-bit numbers are added, the output should be a 5-bit number. Let's open the calculator and see if it is correct. Let's take the calculator as a binary. The first number be 1010 plus. Let the second number be 1100. Let's say calculate. As you can see, the output is 5 bits. Let's make both input maximum and observe the output. Let first number be 111. Let the second number be 1111. Output is 5 bits. The two numbers added do not have to have the same numbers of bits. 2 bits and 4 bits will be added. There must be one more output than the bits with the larger numbers of bits. Let's open calculator again and see. Let's first 2 bits number be 10. Let the second number be 111. The result is 5 bits again. Now let's see the application after loading the code to the card. Let's see the code a little bit. The code begins by including essential libraries. For example, this one provides standard logic types like std logic and std logic vectors. This one enables arithmetic operator on logic vectors. And this one allows using arithmetic operators on logic vectors. Entity declaration. The entity name is added 4 bits. This is the entity name. It defines the interface for the module with the following ports. A is input and set to logic vector and 4 bits. And B is input and set to logic vector and 4 bits. Sum is output, set to logic vector. 5-bit output vectors store the result of addition, including the carry bits. And architecture. Architecture name behavioral. Process block, we know if A or B trigger something and the process will be run. And we have to input A and B, but these are 4 bits and we have to add 0 because we have to 5 bits because sum is 5 bits. If we didn't add this one, the VHDL will be some error. That's why we have to add this one and right and left the same bits. And we generate this stream before and just click Open Hardware Manager, Open Target, Auto Connect. And program device. Program device and program. Let's divide this screen in two. Let's get the board. First, 4 switches for the A input. Second, 4 switches for the B input. And 5 LED for the sum output. Let's see the first example, 0011. A, B is 0011, and result will be 6, 00110. And second example, A is 1011, B is 0110, and the sum is 01111. It's also correct. And the other example, A is 15 and B is 15, and the sum will be 1, 1, 1, 1, and 0 for the binary numbers. And the last example, and A is 5, 16, 1, 0, 1, 1. And B is 1, 0, 1, 1. And the sum will be 1, 0, 0, 1, 0. That is for this video. We successfully implement a 4-bit addition operation on the Basys 3 board using VHDL. In the next video, we will take it a step further and work on implementing a 4-bit subtraction operation. Don't forget to like, comment, and subscribe to stay uploaded with more VHDL videos. See you.